Well, hi, good morning, and thank you so much for joining me here in my shop. If you watched the last two videos, then you saw me run all over this amp, doing all kinds of tests, poking around in every direction. And what was I finding? A strange operation, oscillations all over the place. Hum sometimes, not sometimes. Differential heating of the output tubes. Lots of weird stuff. And I've never encountered something quite like this other than reading about it. I've never actually had something like this on my bench seeming to do all these things. My first thinking is, really, this amp was designed by good engineers. I'm sure it's a good design. I'm sure it came out of the factory without all those things happening. So there must be something that has changed since this came out of the factory to cause this. So right off the bat, I did notice these 4 100 ohm resistors, which I'm going to focus on now. This is the target that I'm going to focus on. The purpose of the 100 ohm resistors is to snuff oscillations, and isn't that the problem I'm having in this radio? One of you sent me some interesting material to read, which I read through, and in it is a statement exactly about these resistors. And in a ultralinear amplifier, which this appears to be, it is quite common or necessary to put a small resistor on the screen circuit of the output tubes. And here's the key thing, ranging between 50 and 100 ohms. So these are 100 ohms. That range stated in that document, that's the top, 100 ohms. But none of these are 100 ohms anymore. They're all 110, 120, and one of them, this one here, is 145, I believe. So if the typical range of resistors is 50 to 100, and these are running over 100, maybe they're not doing their jobs anymore, and this is where all this howling and oscillation is coming from. So pretty easy to change all these out. I'm going to do that. And then we're going to operate this amp and we're going to see what happens. And then I'll carry on to find out what the real problem is after that. Okay, so I was merrily working away here, just trying to remove the different resistors from the terminals here, and I think I may have found the problem. Have a look at this. Okay, so that 2-part resistor was in one part until I grabbed it with my pliers and just pulled it slightly. Not enough to do that. It just came right apart. It just came right apart. So if any one of these tubes decides to oscillate, they're all going to join in on it because everything is connected to everything through these output transformers, essentially. So any one of these guys starts going, and before you know it, that oscillation will be everywhere. So I'm pretty excited about finding that. Can't be absolutely sure though, because I measured all these resistances numerous times. Come to think of it, this is the one that measured high. This one measured 145 or something like that. I think it's a little higher now. So anyway, hey, this is good. Optimism is running wild in the shop here. Doesn't have to look nice and neat. My supervisor took the day off. He's not going to check my work today. I can get away with stuff. Let's get these little tails off here, which are camouflaged. Lost track of that one. Two close short circuits here. Let me just bend this forward. And likewise with this. There. Okay, this is the big test. We have reached the point of testing this guy again. So we have inputs still shorted. Speaker wires still coming out of the inside, not on the outside. Still have these yellow big question mark capacitors sitting in there. Did this do it? Again, my mouse is not going to help with this, Jim. I'm excited, that's why I'm doing stupid things. There. I think we're all set. Okay. The dim bulbs. I guess we're just listening here. I didn't really set myself up to test for anything. Full power. And what we should hear, ideally, nothing. Not even a hum. Okay, I can deal with a hum. No squealing. No squealing. Let's take a look. Let's get the scope going here. I should have fired this up earlier, but you see, I'm too excited. Just got too excited. So the oscillations were apparent virtually everywhere in this amp. So I'm going to look across the screens here. Nothing. Nothing. Arr! Well, that's interesting now. We got nothing and nothing here. Nothing and nothing. You know what? There's nothing and nothing on this transformer, output transformer or channel. Something still on this one. Well, what's the difference? What is the difference? We just didn't quite succeed here. We seem to have succeeded here. Let's go hunting for some more here. Maybe there's oscillations somewhere. Oh, there are some up here. Not done. That guy's oscillating there. I know this is hard for you to see this in the scope, I'm afraid. And I'm not going to do anything about that right now. This other one. What's with all that noise over there? Nothing much happening here. A little bit. Okay, using this, and I know this is going to throw the amp off, but let's look here. This is the grid to plate connection on the left channel, if I can call it that. Straight line, grid to plate connection, oscillation. See the hum level changed a bit? I think maybe that hum is just another kind of oscillation. What do we do about this now? I thought we were going to be all done. You bum. Okay, that's a ground terminal. This is the output of the preamp heading towards the power amp. A little bit of oscillation there. This is right on the B plus supply line, no oscillation whatsoever. So there's a plate and a cathode. Actually, I don't know which one's which offhand. So here's maybe the cathode side. Oops. Am I touching stuff in there? I guess I am. Oh yeah, I see what I'm touching. The hidden resistors. But if we look at the other side, oh, There's a little bit there too. Sorry again, it's such a long shot for you to see this. Here they're gone though. Not quite. Should I put 50s in here? No, I should follow the design. So there is something going on here still. Something more going on. Rats, that's really not what I wanted to find out. So I tried picking up the oscillations that are coming out of this on my SDR radio all the way up to 200 megahertz. Couldn't find anything, not a conclusive test. I'm not sure I was really being effective at all in what I was doing. Just trying to pick it up with a sniffer coil here, and I'm not sure it worked. So, but a new theory, something that should be in my head all the time, is that these oscillations I'm seeing, maybe at this point in time, since you don't hear anything out of the speaker, are oscillations generated by the test equipment itself. So just putting a long lead on here has the potential to create a oscillation. Now, just temporarily I unplugged the scope lead from the scope. Let me plug it back in as soon as I can spot where it went. Where'd it go? Where did it go? There it is. Right in front of me, of course. Yeah, so there's the oscillation. Someone suggested I just speed up my scope and measure the frequency. It's right up near the limit of the scope. So, and it's jumping all over the place right now. So one wavelength looks something like that. A couple divisions. It's well within the range of the scope. I would put it under, I don't know. Turn this down here again. Well, none of that was terribly visible because I got my light on here. Well, so in order to explore that question as to whether hooking up the scope is what's generating this, I can isolate the scope further away by sticking in a nice big resistor. As soon as I can spot one here. Is that big enough? 10K. Well, we can see a difference anyway. So I'm just going to disconnect the scope and reconnect with this resistor in the way. There we go. I have not checked the relative temperature of the tubes yet either, which I need to do. Okay, here we go. Whoops, that's kind of the wrong way. So let's see what's on the scope, and so there's oscillation is still there. It's much less. So you could argue now it's less because the scope can't see it through this resistor, or the resistor has reduced the interference of the scope. I think. Let's go way up here. Same scale of oscillation everywhere. Green. Hey, you know what? Maybe where the oscillation is the greatest is its source. Let's look at this. So that is roughly 1, 2, you could say 2.5 divisions. And over here, another screen terminal. That is 1, 2, it's about the same. This channel's got nothing going in it. Nothing happening in this one channel. Well, come on, other channel. Okay, so a couple things I have not checked is the voltage So those pops you're hearing is me interfering with the audio signal going into the amp. I'm bumping the wires here. So there's going to be lots of popping. Because I'm using clip leads and not in the best way. Incidentally, I've got a radio hooked up here. Let me tune in a station. Probably 95.7 might be a good one.
Connected to the best network in the galaxy.
This gives you an idea what this sounds like.
Smartwatches, tablets,
Sort of.
and more. Visit Bell.ca/Black Friday. Bell, Black Friday just got better. See Star Wars: The Rise of Skywalker in theaters on December 19th.
Ah, she's so happy. Doesn't she sound happy? You can hear the smile when people are doing those advertisements and they're talking like that. You can hear the smile on their face, and it's not by accident. Okay, there's no smile on my face right now. So no oscillation. We were gonna check the voltages in here to see if this is the hopefully 34 volt or so voltage on the plate to grid connection. So plate to grid, let's do it down here. This side is working okay at 30. This side I don't know about. Whoa! 50. I hit the wrong thing. No, I didn't. I did not hit the wrong thing. I've never seen it at 50 before. So that's the plate to grid connection, supposed to be 34 volts. So this is close enough over here, though it's not quite right. But this one's just gone wild. I've never seen it that high before, 46. It's going down. Oh yeah. Disconnect the radio here. So again, this might make a bit of noise. So the input is open circuited now, which is why you hear that kind of hum. Coming in, I'm going to read, it's going to cause pops, I'm sure. I'm going to read the voltage on that grid. Not much of a pop. Same thing, 42, and over here, same buddy over here is 28. It's really definitely something going on. Is that to be expected? That's kind of weird. So what I did there was, oh yeah, this is shorted. This is shorted. It's not weird. Not particularly weird. I'm putting my voltmeter on the input. Ow, wow. Never looked at the voltmeter while I was doing that. There we are. I'm off in the soup again. I was doing pretty good there. Definitely treading water for a while, but back in the soup. Ground side first. And input side next. There we are. We hear the same. So this clip lead is not causing some kind of problem. Good. Now, let's put something on that scope and see what we can see here. Make sure you can see what I'm doing. Exactly the same point on the other channel. Clean as a whistle. There's no oscillation there. So at least I got this happening only on one channel. Now, what about looking for it down on the screens, where we see the hum so distinctly? Look at that. That's about the best look I've ever gotten at this. We know we can get rid of the hum, I'm pretty sure. Here's the other one. Check these ones. Look at that. So there's the hum as a line. And right on the RF, I'm sorry, the B plus coming up here. Oh, it's a little hard to make a connection. Nothing at all. The B plus line itself is clean as a whistle. There's the hum. There's the hum. There is the hum on that part of the high voltage output. The other part is coming up. It's up here where I was testing it. So this is the extra filtered B plus. It looks great. This is the not so extra filtered B plus driving the speakers and probably the hum we're hearing. Ooh, look at that. So I can get rid of that though. That's not the problem. The problem is that stuff. So theory is, or my theory is, if I can knock it out at the source of the oscillation, I will knock it out everywhere, and then I can go for lunch. (120 picofarads). So the first place I'll try knocking out is right where the scope is connected. Surely to goodness I can zero it out there. Okay, onto the ground. Oh, it just barely changes. Okay, so according to my theory, that says that's not the source. And a lot of problems with my theory. That doesn't get rid of it at all. Okay, let's try another spot. Let's ground the grid of the output tubes here using my little capacitor. Ooh, scare me. It causes some weird effect there. There, make it even a little more visible. I didn't get rid of it though. Okay, let's try the other channel. Knock it out with the other. Got too many clip leads in the way here. Okay, just stay there. I'm going to relocate the scope ground to a better spot. Be in my way so much. Back on the. So this is right on the grid. Come on. Right on the grid of one of the two output tubes here. I checked these 1000 ohm resistors that look like oscillation stoppers for the grids, and they're all 1000. There's nothing happening there. Okay, let's try to knock it out again. Right on that grid. Reduced but not knocked out. Right, and the voltage up here is crazy. Last time I measured it. Not about knocking it out. This is a tough one. There's a grid to plate connection. I'm going to try to knock it out on that. A little dark in here for me. Greatly reduced, but not sent home yet. It's still there. There's something really wants to oscillate in here. Okay, we're going to try to ground again this grid with my little, maybe my capacitor's not big enough. Just reduces it there. or I'm not in the right spot. This is not where the oscillation is originating. That's my theory. Theory is if I hit the spot, I couldn't see the scope there. The hum changed. If I can hit the spot, now is there any somehow that the oscillation's over here, but it's seen over here? I can't imagine that, but let's just poke around here for fun. Let me just do this. Nothing happening on the scope, of course. In that case, so what else could I try doing here? Swap those tubes. Swap the tubes. This one's working, this one's not. Swap the tubes. Swap the small preamp tubes here. Should check for temperature differential too. I haven't done that. See if that's still there. I think that's... Swap the tubes. What about the problem? Does the problem swap too? There we go. Son of a gun. I think the hum is over here now. What's on the scope? No, the scope is still showing the same oscillation. Wow, I don't know. My imagination, I think the hum went over here though. Okay, so we're going to come off here and look for oscillation on the side that was not oscillating. It started oscillating. Okay, let's leave it right here, shut it off, switch the tubes back. Switch the tubes back. I have pretty cold fingers, so I can hold a hot tube for a little bit of time here. Actually, these ones aren't all that hot. Swap them. Did the hum move? Did the oscillation go away? It didn't touch the scope. Hum still sound like. Huh. So what I've managed to do here so far is simply infect the left channel with whatever was wrong on the right channel. Or is this coming from my connection here again? Where'd that nice resistor go? I had a nice big isolation resistor. Certainly not that one. Where'd it go? Where'd he go? I don't know. I've lost my isolation resistor. There it is. Presto. See that? Magic trick. Did you see? No, you didn't see that. Yeah, it's still there. So what did I do here? I really made no circuit changes whatsoever. Move these wires onto plugs, but I give that a 0.1% chance of having any effect. Didn't do anything here except move tubes back and forth And now this side is oscillating. Is the other side still oscillating? Did I move it right over? That doesn't make any sense. None of this makes sense. Oscillation there. Oscillation here. Nothing there. It's kind of weird. I thought if it was on one, it had to be on the other. Oscillation there. These are the grids. There. Nothing at all there. Oscillation there. On the screens, big whopping ugly hum. I got to deal with that. I think maybe I'll deal with that next. Screen, plate, screen, plate. Clean as a whistle though. Oh, a little bit of RF in the plate, but the screen is looking great. Maybe that's how I fooled myself. I looked at the screens. Screen full of oscillations on this tube, and likewise over here. These are going through the same output transformer, so if one is generating an oscillation, the other one's going to have it too, including the plates. Look at the plates. Wow, right off the screen. Likewise here. It didn't look so big on the other tube. Plate. There she is, beautifully amplified. A beautifully amplified RF. Tube temperatures, yeah, let's look at that. Tube temperatures. Where's my thermal viewer? Where'd my thermal viewer go? Oh, it's wandering around the house with it. Okay, I gotta go find my thermal viewer. It's missing. So of course one of the other things I'm using this viewer for is checking my house for leaks and stuff like that. You know, air leaks. You know, I live in a cold country, so in the winter it's pretty good if you can track down where your leaks are. If I get this thing adjusted just right in terms of the color range, color temperature range, I can see the cold air coming out of, let's say, a spot in my floorboard or something like that, coming right out and flowing through the house air. I can actually see the cold air itself. It's quite something. This is really cool. I can see the cold air. I can then deal with the cold air. But what about the hot tubes? What about the hot tubes? So red starts around 110. Probably a lot less than that, in fact. Stay put now. Let's see if I can get this onto the camera properly. So I'm going to desensitize the meter a little bit. The red is coming on too soon. So you want to move this up, 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 up. Say 140. So red starts a little bit below 140 now. One. So, oh. Now, did you see that? Yeah, you can see that. You cannot see that. So, there's something funny about this. Okay, so I'm coming across the tubes. Oh my gosh. You know, I think sometimes I can see the element just like you can see it with your eyes. And I think that's part of it. So, first tube. You know what it is? It's the overhead light. That's throwing me off here. Tell you right now, with my eyes, that tube is cool. The heater is not as bright as the rest. But I think this thing shows you something else. Let's see. Let's see what happens here. It does show something else. So first tube. Oh, for crying out loud, you still can't see it. What's going on with these cameras? You can't see enough from this distance. I don't understand it. I have to mess around with these cameras a lot more. Let's try one more time here, or you're just going to have to go with what I tell you. I can see. Isn't that something? So, like my eyes see the red on the screen here the whole time, and you just see a bunch of white. There's something weird about if I tip it on an angle like this, now you can see it, kind of. What's it doing? My camera's fighting with me. So it is. Every time I tip this, it's like shining a flashlight into the eyes of the camera, and it doesn't appreciate it. Hey, that looks pretty good. That looks good. There you go. Finally, 4 tubes. 1, 2, 3, 4. No, don't do funny stuff now. But you see, the one on the right is much cooler. Much cooler. Regardless of what it looks like, because this one definitely, the heater doesn't seem to be as hot. That's neither here nor there. This tube is not running anywhere near as hot as the other 3. That's a consistent finding in here. And if I switch that tube, but I'm not going to do it now, I've done it in the past, I've swapped to and I've replaced it. And it's always running a little cooler than the other 3. What could be the relationship between oscillations and this variation in temperature? Dramatic variation in temperature. Okay, so I've put 2 brand new 100 microfarad capacitors in here. I've paralleled them against the hundreds that are already in there. So now conceivably there's 200, or as much as 200. 200 less a little bit, but I've left the old ones in, which I know is a little bit controversial. But for those of you who do this kind of work, you know the difficulty if you try to remove the connections to the old capacitors, so you don't have terminals for the new ones. So yeah, and that's a big challenge at times. I didn't want that challenge. I got too many challenges here. So we're going to turn it on, see what happens. What else can we do here? Here we go. Can't do it with the mouse again. Fire 1. Watching the dim bulbs. Oh, you know what? I unplugged it for safety. I expect the dim bulbs to... It's going to take longer now. There's more capacitance here. It'll take a little longer to charge up. Here we go. So those capacitors only charge up when the rectifier... Oh, it's their diodes. So yeah. Charged up like that. We're watching for the tube current to show up on the bulbs. Here it comes. Pop. Just one pop. I would prefer 2 pops, one for each channel. I used to get that. We're on full. The same hum is there. Same as it was. Same as it ever was. We'll look at the power supply, see what it looks like. What do we see on the power supply? That's this guy here. I don't think this is the right spot. So this way. So the hum appears to still be there, but be much less. Much less. So that hum would be supplied right through the output tube to the plates of the plates. Let's see. Plate. Slight hum there. Again, it's not what it was. Still hear it quite distinctly though. But did you notice? No RF. Little hum, no RF. What about over here? Giganto RF. And on the last one, plate. Same thing. Giganto RF. And the hum. Hum from here. This channel is this channel, isn't it? I'm not really sure. Yeah, that's that channel. This is this channel. This channel's humming. That one's got the oscillation in it. at this point, if I could beat the hum out of it, I think I'd just carry on and leave that oscillation in there. Oh, one more test. Right, one more. Hey, there's always one more. And I'll take my fantastic patrolman radio here. I'm going to try to patrol the hum. Patrol the oscillations, rather. So we'll put this guy onto, I mean, he doesn't have everything under the sun here. We got airband, UHF. Let's start at the high end of the UHF. High end of the UHF. It's pretty quiet down here, doesn't it? Is that any way coming from this radio? Nope. Something there. Wait, shoot. It's a pretty low frequency though. Higher. There it is. Some of it anyway. Where'd I end up? I ended up at just around 4.5 megahertz. 4.5 megahertz, eh? I have no idea what, what's the advantage of doing this. Just self-entertainment, more or less. Just to get us clear on what's happening here. So around 4.5 megahertz. Well, I'm going to see if I can pick that up on another radio now. Okay, so here's what I've done. Put a coil. Let me just pass the camera right over top here. Yellow coil of wire around the one of the input tubes, hoping to pick up this stuff that's hooked up to the antenna of my SDR, which we are going to look at. Let me just start the amp up first. Okay, let's take a look at the SDR here. Now I know from tuning around on my other radio that there was something around 4 megahertz. Oop, there's one pop. Oh, where'd all that just come from? Wow, that's what's coming out of that amplifier. Harmonics everywhere. Let's go down in frequency. See how low we can go. This one's at 3.2. So I'm going to go down, change the screen 1 megahertz at a time. Okay, there we go. So those signals are coming out of this guy. Now we're down into the AM radio band. A little hard to tell what's going on here. I'm going to flip off the amplifier. We'll see what changes, and it should probably drift. In fact, I can see these signals. I can see 3 of them drifting here. There we go. I'm going to switch off. Yep, there they are. And they're going to drift back. There they are. Wow, right through the entire spectrum. I mean, this is pretty low here. This one is at 1500. How high do they go? Okay, so I'm going up a megahertz a time, megahertz a shot. We were up around 4 before. Don't see much here. 5. Okay, so I'm going to turn the amp off and see if anything disappears or drifts. couple things disappeared. Back on. There they are. So there are signals coming out of this audio amplifier all through the band here. I'm just going to go up in frequency and see if there isn't something leaping out gigantic up here. Okay, so some of that is going to be a short wave stations, but I'm going to kill the amp. Look at that. This guy right here. And the one up here too. Let's go higher. Just keep going up here. Okay, I'm going to kill the amp. We'll see if any of this stuff moves or disappears. Okay, I didn't see anything at that point. We're 14 megahertz here. Let's go up a little higher. So I don't really, so there's a signal at 18,750. Let's see. Turn off. There it is. Turn it back on. The signal's all the way up to 18. So we could double this at 18 and get 36. Why don't we jump right up to 30, 36. Somewhere around in here. Okay, switch off. Sure enough, right where the red line is. Yeah, there's a signal right in here. Oh, I can see a bunch of them drifting into place here. Weak ones. Wow. This is one mess of an amplifier. Okay, so I'm going to call it a day here. It's not really the kind of day I wanted, that's for sure. Hey, since I have this on, let me just take another look at those tubes. Oh, something's on the fire. You know what's on fire? Oh, yeah. Oh, look what happened. Ah! So, I put this on the cooler tube, right? That's a smart idea, but I let this lay against the hot tubes, and look at the mess I made of it. Some smoke coming up here. I gotta get out of here now because it's full of plastic smoke, and I got a tube with lipstick on it. Oh. Yeah, that's the end. That's the end for today. Well, I got lots of stuff to think about here, but I don't feel like I'm getting much closer to the cause. And what? I come in time to knock out the hum with these big capacitors, and it's still there. Jeepers. Okay, thanks. We'll see ya.